Hey everybody, it's me again. Welcome to the COVID-19 version of GIS. So we're gonna try this. I'm gonna try to record some lectures and go from there. So we're gonna start where we left off on Chapter 4, mapping GIS data. So what we're gonna cover here is things like symbolizing features, ways to map data. We're going to skip some of this stuff with some of the raster stuff and the MAUP stuff just because it doesn't pertain to a lot of what we've been talking about. And we never had access to those particular types of data anyway. But we're going to definitely talk about classifying numeric data because that's something you're going to do quite a bit in GIS. And then finally, we get to talk about labels, which isn't necessarily the most fun thing in the world, but definitely labels symbolizing features and symbolizing rasters to a lesser extent are very important decision-making things that you have to do when you're creating maps in GIS. So how do we differentiate the different things in GIS? So things like you can use shape, so different shapes if you have points like points or circles, squares, pentagons. Size to represent, smaller size, let's say smaller population, larger size, larger population. Thickness of the line, obviously, let's say roads. So a thinner line is a less traveled road, whereas a thick line is a more traveled road, or a line type to show, let's say, unpaved roads all the way through interstates. Different color patterns, which we've seen already. There's things like monochromatic scales where you go from a light hue to a dark hue to represent more or less of something. Patterns, in this case, these are geologic patterns. And then obviously font sizes, which you see all the time for things like websites and stuff like that. You can use all caps, different sizes, italicized, underlined, things like that. So using color is one of those things that you got to be very careful of. Humans are very visual beings, obviously, and colors purvey the first thing that you're going to see on a map. And if you don't use the right color scheme, you can really throw off your reader, so to speak. We're not going to go on all the color model stuff, but the main thing you want to get out of this is there's categorical type color schemes, there's quantity color schemes in terms of, like I mentioned before, the monochromatic scale going from a light to a dark color, and then what they call convergent schemes, or excuse me, divergent schemes, which are used for specific purposes. So when you look at the various maps here, you can see the different color schemes being used. So for the upper left middle one, you kind of notice that it looks like something that you would see on a weather map with the blue at the top, probably representing temperature being cold. And you go down to the Florida, the desert, Southwest, and the tip of Texas where it's much warmer typically. So we kind of see that you're used to that on the news, for example. The upper right map, you'll see the little red schoolhouses with the blue plus signs representing probably hospitals. Kind of makes sense, right? So if we go to the lower left corner, what does that represent to you? If you look at that map, it's really hard to discern what that color scheme even represents. It doesn't look like anything. There's no gradation there to tell you there's less of something or more of something. It's using a color scheme that makes literally no sense. And then on top of that, you really only have a couple of different size of dots, mainly two. Because of this, it's really hard to tell, what's a bigger town from a smaller town. Yes, you can see the bigger dots, but there's no differentiation between, or there's not enough differentiation between the biggest and the smallest dots. If we look at the lower middle map, you can see there's a pastel color scheme. Then all of a sudden you have this very bright red color. Now, red is typically associated with things like danger. We use it for stop signs, we use it for siren flashing lights and such. So the overuse of red can be very detrimental to the point you're trying to get across. If you look at a map like that and your house happened to be sitting on that, you'd get nervous. So the other one in the lower left corner, what's wrong with that map? Well, hopefully you could see fairly quickly that that map is inverted. All right. Typically we use blue for water. So the ocean should be blue, and then the land around it, the lower part of the United States and Central America there, Mexico, that should be the beige color. So it's inverted. So that's something you definitely do not want to do. So here we have another map. So again, I'm going to start on the one on the right. So you use the one on the right, and you've seen this every weather, on the 10 o'clock news or whatever news. You got cold at the top, warm at the bottom. There's a gradation in between. But what about the one on the left? So the one on the left is a little bit weird in the sense that you have this what we call divergent scheme where you have red at the top and blue at the bottom. But then look what it's mapping. It's mapping percent Asian. Now, just if you go by what I just said about red, then a lot of times red is typically associated with danger. So are those dangerous Asians? But the weird thing is that not only does the color scheme not make sense, the most bright color in terms of, like I said, danger is associated with the smallest population of the quantity we're looking at, in this case, Asians. So that's definitely the wrong color scheme to be looking at for that particular demographic. So what are we looking at here? So we're going to talk about the items on the right here: nominal data, categorical data, ordinal data, interval and ratio data, and then what type of maps are associated with on the left. So we're going to go through each one of those on the right and talk about how you deal with them, what type of maps they make, and what to look for. So nominal data are data that are unique identifiers. Things like state names. There's only one Wisconsin. The owner of a parcel, the tax ID number, the parcel ID number. So, for example, my house probably has a specific number associated with it that the government, the local municipality I live in can use to quickly look up my house. We all have a piece of nominal data associated with us, and that's our social security number. So not that you would map that, but that is technically a not piece of nominal data because it's a unique identifier. These will play a role later in the semester when we talk about joining tables. So each feature is likely to have its own value. Okay, so again, there's only one Washington state, there's only one Oregon. And what we typically use nominal data for is labels on a map. All right, so if you have all of the states, you want to put the labels on it, that's nominal data. Same thing with, say, counties. You know, those are unique identifiers that you can use later on down the road. So nominal equals unique identifier. That's kind of how you want to remember that. Now, unique identifiers make what are called single symbol maps. And these are pretty much just strictly place name maps. There's no analysis being done here. You're just taking the data, putting it on the map, maybe changing the symbology to make it look a little nicer, like with the stars with the capitals and then the rivers. But there's nothing here other than place names. There's nothing else to look at. Nothing's symbolized to show greater, smaller, or anything like that. So that's what you would use nominal data for if you're just making a map with it. The next type of data is called categorical data. Categorical data places features in a defined number of distinct categories. So let's say, for example, we have the volcanoes, and you've seen this before in chapter 2. Volcanoes are great. So if I drag the volcanoes on my map, they all show up as little circles, and that's great. But if you look in the attribute table, you'll notice that there's different kinds of volcanoes. There's a column in the attribute table called type. And within that column, there's there's different types of volcanoes, and it would be nice to put that on a map. So that's what categorical data is. So within the volcanoes, you can differentiate with stratovolcano, caldera, complex, shield, or volcanic field. And so you can have a different symbol for each one of the different types of volcanoes, and that's really handy. Same thing applies, so that's points. For lines, we use highways as an example. You have unclassified, arterial, freeway, and interstate with a different symbol showing the different kinds of roads. And then again, for polygons, we have land cover. So different shades of color. The colors are pretty much random, but you can make them somewhat systematic in terms of like greens for certain things and water for blue. But again, it's different cover types that's found in a column called cover type, and you use a different symbol for each one. Those make unique value maps. So on the left there, you'll see volcano types. So rather than just have all the volcanoes have a circle or maybe a triangle, we can symbolize each different type of volcano with a different symbol, and that would help people understand what's going on where. Same thing with road types. When you look at that, you can see the thicker lines probably represent roads that are more traveled than the thinner lines. So those thick lines on that map are interstates. And then for geology over on the right, different colors represent the different types of geology. The next type of data is called ordinal data. Ordinal data represents rank. That's what you want to get out of ordinal data. Ordinal equals rank. So it's a type of categorical data, but what it is it's an arbitrary scale. Things like low, medium, and high slope. So you don't know where the cutoffs are necessarily. It's just low, medium, and high. Things like village, town, and city. We don't know where the cutoff for population would be between those. Grades A, B, C, D, and F. Those are arbitrary letter grades. Okay, I could easily go, I'm going to give you an L, M, N, an O, or a P. You know, we just decided to use those. And then obviously the rank of best city to live in. Okay, so that's very subjective. Now, what this is typically used for is very sort of vague mapping, but sometimes that's all you need. You're just trying to get a general understanding of what's going on in an area, like low, medium, and high slope. Where the cutoffs aren't as important as just getting a general idea of where the areas of, let's say, high slope are that might where a failure might occur. The last type of data is two different types of data that we're going to look at are interval and ratio, and those are the numeric data that you're going to deal with most often than not in GIS. So interval data places values along a regular numeric scale, and it allows for addition and subtraction, such as temperature, pH, and elevation. Now, what makes that important is the fact that those values can be negative. You can have negative temperatures. We know that all too well in Wisconsin. You can have not negative pH, but pH is a logarithmic scale that never goes to zero. And then elevation can also be negative. Things like the Dead Sea and Death Valley in California are below sea level, which is considered negative elevation. The other one is called ratio data. Again, it's numeric data, numbers. It's data that places values along a regular scale with a meaningful 0 point. So it supports addition, subtraction, multiplication, and division. All right. So things such as population, rainfall, and median rent. Now, you'll notice population and rainfall, especially, you can't have negative values. Zero population means just that. There's nobody there. Whereas negative rainfall, or you can't have negative population or negative rainfall. So interval can be negative, ratio cannot be negative. It only goes to zero. As you do GIS, these become second nature. It's one of those things that you have to understand the concept for Chapter 4, obviously. But when you start dealing with GIS in any form or fashion, you'll realize that this stuff just, oh, it's temperature. It can be negative, and you know what you can and can't do with it. You don't have to sit there and think about this stuff all the time. But the concept in the beginning is very important to understand. So how do we map numeric data? So you have to divide it up into classes. Sometimes I call them bins. It's an old term that I just can't seem to let go of. But you have to divide it into classes. What those classes are the starting and stopping point for each one of the symbols. So if you look at cities, for example, the smallest dot goes from 8,200 to 300,000. So that's one class. The next one goes from 310,000 to 1.6 million. Now you'll notice there's a gap in there. I get that. I don't know who did that, but usually there shouldn't be a gap there. All right, but the idea is these have the first two, the three dots have three classes. The three roads have three classes, and the precipitation has four classes. Now you have control over all of this in the program. Okay, you have control over how big the dots are, what color the dots are, and how many classes you have. And all of that is, you guessed it, a drop-down menu. It's all drop-down menus for this. Now, to make those numbers nice and round like they have there with the commas, That takes a little bit more. You have to actually do that manually, but it's very quick and easy. It's not a hard thing to do at all. All right. So typically, I think by default, ArcGIS gives you 5 classes to deal with. And so you just want to understand that, okay, you can have less than that. You can actually have way more than that. 5 is usually sort of the sweet spot for most things, but not always. So what this allows you to do is make what are called class maps. Okay, so there's 2 different kinds. There's the graduated color map, otherwise known as the choropleth map, which is about the only time you'll ever hear me say that, and a graduated symbol map. So for example, using the population per square mile data there, you'll notice there's 5 boxes, so there's 5 classes, and using those classes, those cutoff values like 1 to 92 and 93 to 232, you get the idea. That's the map you come up with. And it's pretty much what you should expect. Those smaller states on the East Coast have a lot of people crammed into a small area, whereas a place like Texas has a lot of room to roam, and they have less population density. That's what that is. And then for the map on the right, we're using what's called a graduated symbol map. So the smaller the star, the smaller the population, the larger the star, the larger the population for the capitals of the 50 states, well, the lower 48, that is. And so the largest stars being 2 of the largest are in Phoenix and in Indianapolis. And you could see the breakpoints, the cutoff values 8250 to 57300. Now, where those actually fall is up to you. You can round those a little bit to make them nice, even numbers. And I strongly suggest that because humans don't think in terms of 57300. I would have just rounded that to 5700 or 57,000, excuse me. A small amount of rounding isn't going to really alter much. The next one is 140,000. That's a good number. Nothing wrong with that. Um, but you can round up and down just to make them nice, round, human readable numbers. So I've already mentioned colors for choropleth maps before, looking at what to do and what not to do. And more often than not, you're going to use a change in saturation or hue for values, what we call a monochromatic scale. That's what the map on the top shows. And hopefully this all makes sense. The lighter the color, the lighter the value, whatever the value is. The darker the color, the more of the value in that particular, in this case, county. So the problem with the map on the bottom goes back to that percent Asians example I gave you before, is that color scheme doesn't tell you anything. What does blue mean as opposed to orange? There's no breakout pattern that can really help you with that. Another thing you can do with class maps is what's called normalizing. So normalizing just means that you're dividing by a certain number to help reduce the overall impact a larger area will have. For example, if you look at the map on the top, you'll notice that Texas is by far has the largest number of farms. Well, why would that be? It's because Texas is one of the largest states in the country and they have plenty of room for farms. So you would expect that. So that map of alone really doesn't tell you much in terms of the overall impact of farms on a given state. However, if you take the number of farms and you divide that by the area of each state, you get the map on the bottom, which shows a whole nother story. Here you can see Iowa, for example, is now very dark green because Iowa has almost nothing but farms for the size state it is. Now, both of these again are going to be drop-down menus in ArcGIS. The first drop-down menu is you'd say, okay, the number of farms, and then there's a drop-down menu right below that, which is typically set to none because you only need that one if you're going to normalize something. But you put it to, let's say, divide it by shape underscore area, which is the most accurate field for a feature class setting in a geodatabase because it's automatically calculated for you in the program. We also have what are called unclassed maps, which are just things like proportional symbol maps, where it gives you a star based on its population. You have no control over those breakdowns. It's just kind of done automatically. It's kind of a quick and dirty way to show proportional values, in this case, population. And then on the right, you have what's called a population density map. Those dots are randomly placed, so they just represent a area of densely populated places. For example, you could see California, pretty much all of the East Coast, Florida, the Chicago, Illinois, Wisconsin. But places in Wyoming or Montana, you expect fewer dots because there's fewer people. You can also make chart maps in ArcGIS. Now, this would work great for things like demographic data, um, like we have available with the program. But just it's not something you're going to use a lot, but it is an availability. They're really easy to use, and if you have the right kind of data, it can make a great impact to try to get your point across. All right, so we're going to talk a little bit about displaying rasters now. Now, we don't do a lot with rasters because we didn't have the license type to allow us to utilize a lot of the tools that rasters would use. But there are two kinds of rasters. Now, if you remember from a while back, raster is like a picture. Think of it kind of like the picture of your phone. And in that picture, you have what are called pixels. Each pixel represents a color, and then putting all those colors together, you get an image. Well, rasters are like that in GIS, except rather than an image, you're getting, let's say, elevation or land cover or precipitation or temperature, things like that. So there's two kinds of rasters. There's a raster that's called discrete, where you have large areas of the same value. So if you look at the upper map on the right there, you have a swath of blue with the value of 10, a swath of pink with a value of 14, another bit of blue up in the upper right corner with 10. You have the beigeish color with 15 and the green color with 9. So you can imagine this is land cover where both the 10 values are blue, and so we'll call those water. The 14 is pink, which is typically kind of used for urban areas. 13 is a beige color, which is typically used for agricultural, and then obviously the green we'll say is a forest. So if you think about this in the real world, you're not going to have one square that's going to be urban, and then the next square is going to be forest, and the next square is going to be agricultural. You're going to have large areas of all of these values. Same thing with water, obviously. You're going to have a lake. So they change abruptly at boundaries, but they don't change um, every cell value, for example. Now, if you look at continuous data on the bottom there, you can have thousands or even millions of potential values. So each cell of the raster, if you're looking at a picture, it would be a pixel, but in raster world, it's a cell. Each cell can have a slightly different value. And when you take all these cells together, they represent sort of a surface where the values are changing rapidly from cell to cell. So if you go outside, you know, it's hard to see this in the city, but if you go out, get out of the city, you'll notice that, elevation changes a lot. So you might have little hills, you might have a dip here, dip there, maybe a cliff. There's always little changes going on in the elevation. It's not perfectly flat. So that's where a continuous raster comes in. Each cell represents sort of that continuously um, changing surface. So there are two types of main rasters. The one that we would be dealing with in the program would be thematic rasters, things like what's called a digital elevation model, or DEM, which shows elevation. That's what that picture is in the upper right. Or a discrete raster like the one you saw on the previous slide with land use values. And then you have what are called image rasters, which are satellite or air photos, which we wouldn't be dealing with too much anyway in an intro class. But those are usually represented by brightness. So 0 is black, 255 is white. And they're usually continuous as well because there's a lot of gradation in there. So how do you display thematic rasters? Well, you kind of do it similar to interval and ratio data, where you have or a categorical and ordinal for unique values or discrete colors, and then interval and ratio data is similar, to what we talked about before with vectors. The one that you're going to deal with more often than not is on the right, where again, you can specify, if you put it into a classified scheme, you could specify the starting and stopping, the number of classes, the starting and stopping of those classes, or you could use what's called a stretch value in the lower right, which will allow you to create a smoother looking surface on your map. And that's typically what that's used for. Now, there are reasons for using one or the other. A lot of it has to do with further analysis. For example, using a classified raster scheme will allow you to quickly identify and possibly pluck out values you might need for further analysis, which we don't cover in this class, but things for like using overlays with the raster calculator. So there are reasons for using both types of classification schemes. Again, we're not going to talk too much about image displays. Mainly the fact that there's two main types: the single band image, which is like a black and white image, and then you have the three-band composite image, which is satellite imagery where you have multiple sensors that are bouncing information down to Earth, and when it's received back to the satellite, it's received back in different wavelengths, and then you can change those filters depending on your needs. So the one you see on the right is what we would see with our naked eye from space, but you can change those around to look at other types of color schemes. For example, you have true color, false color, and then sort of a hybrid. And each one of these is used for different purposes. For example, true color is obviously what we're using with our naked eye. False color is used for things like urban growth. This is a branch of science called remote sensing, which you can do a little bit in ArcGIS, but there's programs such as ERDAS and Adrizi that are much better at it. You can look at things like urban sprawl, the overall health of agriculture, snow, reflectivity, what they call albedo. All kinds of things can be used with this. There's also index color rasters, which we don't use a whole lot. These are scanned maps essentially, not used too much anymore. Now, when you're dealing with rasters, one little handy thing you can do is what's called transparency. So when you're using the program, you can kind of make one layer you could kind of make it see-through, which gives a nice rugged look to your map. So if you look on the left, you have geology, which is our vector class, feature class, excuse me. And on the lower one, you have hillshade, which is sort of just a lighting effect. So it uses the elevation of an area, combine that with the angle of the sun to give you a shadow effect, that ruggedness. And so we could make the geology layer, which is on top, partially see-through, so you get sort of the best of both worlds. You can still see the colors of the geology combined with uh, the ruggedness of the terrain. Now, when you're classifying data, there's 6 main classification schemes, and I'm not going to go into all of these. The book does a better job covering all of this. What I will tell you is most of these are not used very often. However, the first one, the Jenks and natural breaks, letter A in the upper left corner, is by far the most used, and it is the default classification schemes. Now, this applies to both vector and rasters, okay? You can also do this manually as well, but just know in the book that it's going to mention some of this, and that A is typically used for almost all data. It's still the best of all the classification schemes. All right, so we're going to kind of switch gears here. We're going to talk about dynamic labels. Now, when you say dynamic labels, it sounds really complicated or fancy. What that really is just allowing the program to turn the labels on for you and use them, you know, sort of manually or automatically, excuse me. You can turn off on and off labels for layers. You can, however, when you use dynamic layers, when you allow the program to run them for you, they're redrawn each time the map view changes. It uses auto placement, and sometimes what can happen is it can change between what you see on the screen and if you print the map out yourself. So these are sort of the quick and dirty labels, if you will, that allow you to just turn them on and then let the program handle the rest. Now labels are very important. Your map should have some labels of some sort because again, humans need to be able to read something. Just the picture or just a map alone is going to be awfully hard to decipher without some type of labels on it. So the labels are in the right-click properties. You remember that? Right-click properties, go to Labels tab, and if you turn them on with the upper left corner checkbox where it says Label Features in this label. So that's where, or in this layer, excuse me. That's where you turn them on. And then the label field right there in the middle where it says Name, that's the field in the attribute table that's going to have the labels placed on them. And then you could see where it's circled there, the placement properties, you have absolute complete control over where those are going to be. So just to give you an example, here's the point placement properties, and you can see that by default, you'll see the offset label horizontally around the point. You'll see the 1s, 2s, and 3s there, with 1 being the optimal, for the preferred place to put the label, top, right, all allowed. So what the program is going to do is look at the number 1 slot, and if it can put the label there, it's going to put it there every time. If it can't put it in number 1, it'll try one of the number 2 spots, and then it'll try one of the number 3 spots. Now you can see over on the right, every permutation known to man is in there. You could get really OCD about all this stuff. I've never ever changed these. It just seems kind of silly to do so. Uh, but this is with the assumption that you have a lot of labels and you want the program to try to place them as perfectly as possible, which usually works, but you'll see that there's some exceptions to that. So here's the Polygon placement label options. So you can have them always horizontal, always straight, or try horizontal first, then straight. So there's fewer options than a point because it's trying to fit that label within the polygon itself. Then you have the line options, and you have horizontal, so it's always going to be horizontal. You have parallel, which will try to parallel, let's say, a line. In this case, you see in the middle a river. Then you have one that's called curved, which is kind of fun. If you're labeling a river, it kind of makes the label follow the general curvature or path of the river segment itself. So that gives a little added nuance to the map that maybe you didn't have before. Typically, what you're going to do when you're labeling on your map is use what's called the label toolbar. There's lots of toolbars, and this tool is very handy for quickly just placing labels. You can literally click and it'll place it on there. It gives you options as to what to do if the program is uncertain where to put a label. You can see a few labels on the map on the right that are in red. Those are overlap labels. The program's saying, hey, what should I do with these? Do you want me to place them? Do you want me to delete them? Do you want to move them? What do you want to do with them? So you have complete control over this. Now, I personally have never made a map with that many labels on there, so I've never really run into this issue too much. But that is an option that you can use definitely when you're labeling your features. Now, when you're assigning labels, or excuse me, symbols to your feature classes on your map, you have to really keep in mind what you're trying to map, and you want to assign the symbols appropriately. So, for example, on the left, you have volcanoes. Those are all symbols that, at least somewhat represent something that might have to do with volcanoes. Same thing with highways, same thing with land cover. You want to choose symbols that matched what you're trying to get at. So in ArcMap, there's different styles. In fact, there's quite a few styles. By default, some of them are available. Other ones have to sort of be turned on. And the styles are grouped together. For example, the ESRI style, which you guys have already seen, star number 1, triangle number 3, square number 1, circle number 1. You've seen all those, okay? They're usually grouped together by theme. Well, there's a whole bunch of those. And the problem is if you turn them all on, you have to scroll through this long list to find everything you're looking for, and you don't want to do that. So you typically only turn on what you want when you're going to use it. Now, in the program itself, when you're making the maps, you have to, this is where you have to understand the type of data that you're going to be mapping. And we talked about that earlier with the nominal, ordinal, categorical, and then interval ratio data. So if I know I'm going to be using one type of map, or excuse me, one type of data, what type of map should I make? Well, in the program, it'll in the symbology it'll ask you what kind of map do you want to make. Now these are little flyout menus, so if you double click on categories, it'll fly out. If you double click on quantities, that's what you'll see: graduated colors, graduated symbols, proportional symbols, and dot density. So you actually have to click on the word quantities to get to that. So like we saw before, there's different types of map involved with different types of data. So if you're just using nominal data, you're going to use a single symbol map. We talked about that earlier. There's nothing much going on there. It's just place names. You're throwing things on a map just to kind of show people where things are. With categorical data, you're going to choose the unique values map option. Then you have ordinal data, which depends on whether that ordinal data is numeric or non-numeric. It'll kind of dictate whether you use unique values or graduated color. And then interval and ratio data, which is all your numeric data, you have lots of options. Most of the time, I will tell you though, like 99% of the time with interval and ratio data, you're going to use graduated color, especially for polygons, or graduated symbol for points and lines. The bottom two, dot density and chart maps, are very specific. Very rarely are you going to use those. It's going to be graduated color, graduated symbol for different types of those types of data. So when you open the symbology tab, now you'll see over on the left there, it says features, single symbol. That's the default one. So if I drag, let's say, states onto my map, by default, they're all going to show up as the same color, whatever random color GIS decides to choose. So that's kind of boring. We don't want to keep it that way. So you'll see on the left, there's categories and quantities. So I have to click on one of those to tell the program, hey, I'm going to either subdivide it by categories, or I'm going to use some type of quantities from my attribute table to make this map look a lot different than it is now. So here we click on categories, and you'll see the value field where it says subregion there, sub_region. The value field is a drop-down menu that represents all of the columns in your attribute table that you can possibly map. And for this, because these are not numeric, this is categorical data, we would use unique values. In this case, subregions. So the country's divided by up into, I forgot how many, 12, 13, something like that. Subregions. So you can see Wisconsin is in the upper Midwest one. It's a little off you'd have to scroll down. I think there's like 10 of those. But that is categorical data. You'll see the color ramp where it has all the different colors. Those are what's called the random pastel. So the colors are assigned randomly for this particular color scheme. Now, for a graduated color map, I would click on quantities and you'll get those four options. Graduated colors, graduated symbols, proportional symbols, and dot density. Now, if you look, you'll see there's another field for value, that's where it says POP 2010. And right below it is that normalization field we talked about a little earlier, where if you were going to normalize the data, you could do that by another drop-down menu telling the program where to divide it by. So if I wanted population density, I would use pop 2010 and divide that, use the drop down menu where it says none right now, and change that to area of some sort. And it'll automatically calculate it for you. No math needed. Over on the right, you'll see the number of classes is set by default to 5. Now the class start and stop points, which we call breakpoints, right now, for example, it says 548154 to, oh, those are hard to read. You see what I'm saying there. Those are default values, which you would want to change and probably make it look a little prettier with things like comma separators, because whatever is on there is automatically put onto a legend if you put an add in the legend to your map. Now, when you're using interval and ratio data, you're also going to have to use the classification scheme. You'll see the classify button right next to the number of classes. We'll get to that in a second. So here we are normalizing the data. So you can see where it says under the SQMI, that field's been added for you. So you're taking the top drop-down menu where it says number of farms 07, dividing it by the area, and now that gives you the number of farms per area, which is sort of a farms density type of. You can see on the map, again, Iowa gets that dark green, sort of the Ohio value, Kentucky, Indiana, Tennessee, and Ohio. It's a whole new map just for the simple fact that you divide it by the area. And again, the math is super easy because it's all done for you. You just have to tell it which one you're going to use in the value field, which attribute you're going to use as your value, and then what are you going to divide it by, and the math is all done for you. And once you do that, again, you have choices as to the number of classes you want and the classification scheme. Making a graduated symbol map is pretty easy as well. So if you look right now in the value field, it says pop underscore 2000. So that's the attribute field, the column in our table that we're going to use to make a graduated symbol map. So the symbols right now, there's 4 classes. You'll see there's 4 classes there, and that's okay. In fact, that was probably the default. And then you'll see the different classes, the start and stop points, 24 to 16354. But you'll notice there the symbol size from values. So it's from 6 to 20. Those are the size of the symbols that are going to be used, in this case, the yellow stars. So the smallest value is 6, and the largest value is 20. Now, just from experience, I typically bump that 6 up to 8 because the value 6 is very hard to see even on a computer screen. Okay, but you can control that. You go from 20 to 25 if you want an even bigger star. But I would suggest changing that 6 to an 8 just from experience. Now you'll see there's a template button there on the right as well with the yellow star. So if you didn't want yellow stars, let's say you want green triangles, that's where you would change that. It changes the symbol for all of them, but still maintains the size values from 6 to 20, for example, in this particular slide. The same thing applies to lines. So in this case, rather than the size of a symbol, you have the thickness of a line. So right now it's going from 0.5 points to 4 points. Okay, and those are actually pretty good values. Again, there's 5 classes you can see over on the right, and there's a template button. So if you want a different color, a different type of symbol used, you can change it there. But 0.5 to 4 like that is pretty good. 0.5 is sort of your typical size for a normal line. So it's easily used for the thinnest of the lines. Just like vectors, we need to classify rasters as well. And you could do the same sort of thing, although typically you're going to use a few more classes. In this case, there's 20 classes, which is probably a bit overkill. But you get the idea. You can pare that down to what you need in order to get your point across. You can also use the stretch value. The stretch value automatically bends everything up for you and gives you that smoother feel to what the raster looks like on your screen. For the single band image, you have just, again, it's a black to white. 0 is black, 255 is white. And for a multi-band image, you have the red, green, and blue values, and you can change those. We're not going to get into this too much, especially without being able to do the tutorial, but you can change those drop-down menus for different colors to get the different color band combinations, like that weird green to pink color that you see on the lower left.